Hey A&Pers, this is Dr. Jones checking in. This is A&P 2, Lecture Test 5, video, I think this is video 5. Last one I've written down is video 4. Video 5. And for the note set, I'm at the top of page 10. Is that where y'all are? It says we did 8 and 9 in the previous video, so go on with it. Okay. So, I'm not sure. I think we looked at this picture in the last video, and you can see the kidneys, the ureters, the top of the urinary bladder. You can see the renal artery going in, the renal vein coming, renal arteries going in from the aorta, the renal veins going back to the inferior vena cava. Your psoas major, your iliacus. And the kidneys, which we have discussed and drawn. Oh, and the renal sinuses show up better on these pictures. You can see there's fat and blood vessels in the renal sinuses. And then here's the official drawing of the blood vessels. We drew this. I drew this for you in the last video, but let's go ahead and follow them again on the drawing just to make sure that we're clear. So we've got the renal artery, splits into segmental arteries, interlobars up the sides of the renal pyramids, arcuate arteries arcing across the top, cortical radiate arteries radiating out. The rest are probably behind me. Yeah, there we go. There we go. And then the afferent arterioles coming off of the trees, they're the branches, and then the glomerulus is the little knot of capillaries that we will learn more about here in a second. And then you've got no paratubular capillaries? Okay. Efferent arterioles and then paratubular capillaries, and here we'll have vasa recta, and then cortical radiate veins, arcuate veins, interlobar veins, and then again no segmental veins. We go straight to the renal vein, and you can see that here that we skip the segmental veins, renal artery, segmental arteries, interlobar, arcuate, cortical radiate, afferent arterioles, glomerulus, efferent arterioles. Paratubular capillaries are in the cortex, in the medulla. We have the vasa recta. Venules, we don't have any venules on here that we're learning. And then the cortical radiate veins, arcuate veins, interlobar veins, skip segmental, straight to renal vein. Both lecture and lab material, except venules. We don't have venules in the lab. Okay, page 10. Nephrons are the functional units of the kidneys, and they have two parts. The renal, hello. I was going for a pen. I don't think red's gonna show here, and black's the same color. How about cyan? Oh, that looks terrible. That kind of matches the thing at the bottom. We're going with it. It shows up. That's the important part. So the renal corpuscle is this outer part. It's the cap. And it's this, actually, the renal corpuscle is this whole pearl. The whole pearl is the renal corpuscle. And it has parts that we will learn the names of. And then the renal tubule, which again has parts that we will learn the names of. Next, the renal corpuscle is a spherical structure consisting of the hollow Bowman's capsule, which is this outer bit, or glomerular capsule. So Bowman's capsule and glomerular capsule are the two words for the same thing. And they're around a knot of capillaries called a glomerulus. Sorry, I just woke up from a nap. Blood is delivered to the glomerulus via the afferent arteriole, and it is carried away via the efferent arteriole. Together, the fenestrated endothelium, the basement membrane, and the foot processes, which in lab we're calling pedicels, of the podocytes form the filtration membrane. Oh, okay, we were on this slide. Filtration membrane. There we go. In the process of filtration, The blood pressure forces water and dissolved solutes into the capsular space, and that drains into the renal tubule. The filtrate is the plasma minus the proteins that get filtered out. So it's the fluid in the capsular space. So let's break all of that down, shall we? Okay. Here we go. Okay, so the renal corpuscle and the renal tubule are the two main parts of the nephron. The renal corpuscle has this cap that surrounds it, and that's the Bowman's capsule or glomerular capsule, and then the knot of capillaries. So the efferent arteriole drains blood out of the glomerulus, and it has a smaller diameter than the afferent arteriole. So lots of blood enters the glomerulus, but like 2 men enter and only 1 man can leave. So what happens here is the decrease in diameter at the efferent arteriole jacks up the blood pressure in the glomerulus and forces fluid out. And these are fenestrated capillaries, just like we had in the hypophyseal portal system. And the little pores allow lots of fluids out. There's a whole filtration membrane thing that we'll learn about here in a minute. And that forces the fluids into the capsular space. But the filtration membrane catches the red blood cells and all the large proteins, most of the proteins, all the proteins except the albumins. And so you end up with this filtrate in the capsular space. And you end up with actually quite a lot of filtrate. And we need to turn this filtrate into urine. So what this tubule is going to do, and tube is wrong on the lab test, it needs to be tubule. The proximal convoluted tubule primarily reabsorbs the good stuff that was in the filtrate that our body wants to keep, like ions and nutrients like sugars and things. Amino acids probably should be there. And then the descending loop will function to increase the concentration of the tubular fluid. And then the distal convoluted tubule will take other wastes that are in the bloodstream and put them into the tubular fluid so that they will get peed out. And then there's lots of other things that you can do here that we will discuss. Okay, basic concepts. The fluid in the bloodstream, the fluid portion of the blood is of course plasma. And the fluid in the capsular space is filtrate. And the fluid in the tubules is tubular fluid. And once it hits the minor calyx, it is then called urine. So, the kidneys remove waste from the blood. They regulate blood volume, blood pressure, ion level, blood pH, all of it. Yeah. Okay. Okay, explain the difference between filtrate and tubular fluid. I think I just did that. But let's do the part that we write down. The filtrate is, well, there's two differences, the location and the composition. The filtrate is in the capsular space, the tubular fluid is in the renal tubules. The tubules change the composition, they reabsorb water and nutrients and secrete wastes into the tubular fluid. So as this filtrate becomes tubular fluid, it is altered in a way that turns it into urine. Because that's the whole point of the kidneys, is to make urine. The regions of the renal tubule and their main functions, I think I just did that too. I was ahead of myself by like 3 lines on the note set. Proximal convoluted tubule reabsorbs water and critical ions. The nephron loop concentrates the tubular fluid. DCT, distal convoluted tubule for lab, DCT, we can call it DCT and PCT for lecture, but you will need to write those out on the lab test. Secretes waste and fine-tunes the absorption of water and ions. The juxtaglomerular complex, let's see if we have a slide for this. Here we go. The juxtaglomerular complex is this thing here, and it regulates blood pressure and filtrate formation. The macula densa are these cells in the distal convoluted tubule. Distal convoluted tubule always runs between the afferent arteriole and the efferent arteriole. I don't know if you've watched the lab list. I should have said that in the lab videos, but in case I didn't. Distal convoluted tubule, DCT, always runs between the afferent arteriole and the efferent arteriole because these macula densa cells face this hole. They're part of the juxtaglomerular complex. Macula densa includes chemoreceptors and baroreceptors. The juxtaglomerular cells are these cells here in the wall of the afferent arteriole. And they monitor the blood pressure of the afferent arteriole, and they secrete renin, R-E-N-I-N renin. So our kidney renin, not the stomach renin. The stomach renin is R-E-N-N-I-N, and that's what we use to make cheese because it coagulates milk. This is the R-E-N-I-N renin that starts the renin-angiotensin-aldosterone system, whose whole thing is blood pressure and blood volume. And where is blood pressure and blood volume super important? In the kidneys. So. And then we also have extraglomerular mesangial cells, and they coordinate the macula densa and the juxtaglomerular cells. Next page. Each renal corpuscle includes a glomerular capsule, and a glomerulus. Is the glomerulus labeled here? No. Okay. And draw a renal corpuscle. Okay, so we're gonna whiteboard this. Nope, nope, nope. Yep. Okay. I just woke up. I'm not quite awake yet. I apologize. Education must go on. Okay. So I cannot draw a knot of capillaries. So I'm going to draw like a U. Okay. So you have your afferent arteriole bringing blood in and the efferent arteriole carrying blood out, but with a smaller diameter. And then this is your glomerulus. And it contains blood. Okay. Now, the walls of the glomerulus are capillary endothelium. That's an E. Endothelium. There we go. Okay. And as you recall, those are fenestrated capillaries, so they have holes in them. So the whole knot is a glomerulus, and the cells that make up the walls of the glomerulus are capillary endothelium. Now, surrounding the capillary endothelium, touching, but I'm drawing with a mouse, so we're doing it. We're going with it. Okay, that's touching. Is the basement membrane. Because under an epithelium, there's always a basement membrane. Membrane. Okay, and then there's another surface next to that. Hello, I want a different color of pen, please. Thank you. Going with blue. So again, touching, which again, I can't draw. This is the glomerular epithelium, which I should label up here, but we kind of need it twice. And then these three together are the filtration membrane. Okay, so this layer continues, and it's the same layer. I'm changing color just because it has a different name, but it's the same stuff. Okay, so this is the capsular epithelium layer. It's also called the parietal epithelium. Okay, and this here is the proximal convoluted tubule. So this is the capsular space. Excuse me. And what's the name of the fluid in the capsular space? Filtrate. And then once it enters a proximal convoluted tubule, it'll be tubular fluid. It will continue to be tubular fluid throughout the nephron loop, the distal convoluted tubule, the collecting system. Once it enters the minor calyx, it is then urine. So I told you we would need this term twice. This is the glomerular, such a weird word, which is also called the visceral. I kind of like that one better because it's touchy. Epithelium. Now, these two together, these two layers, are your Bowman's capsule. And the Bowman's capsule also has a second name because everything needs a second name, apparently. And that's the glomerular capsule. Either way, the two together are a capsule and each individually are an epithelium. So the parietal epithelium and the visceral epithelium make the glomerular capsule, or the capsular epithelium and the glomerular epithelium make the Bowman's capsule. So there's that. Okay. And then we should make note, oh, we haven't done magenta yet. Of the distal convoluted tubule. Probably make circles for nuclei, but. And these cells are meant to be the macula densa. There you go, one more. And then these cells are the juxtaglomerular cells. Juxta here we can use to mean just next to it. These cells are just next to the glomerulus. And I think we're going to have to mark over things here. So the juxtaglomerular cells and the macula densa together make the juxtaglomerular apparatus, in addition to the extraglomerular mesangial cells, which I don't know where to draw. So juxtaglomerular complex, juxtaglomerular apparatus. Either way works. Glomerular. It's the adjective form of glomerulus. It's just annoying to say. Juxtaglomerular. Complex. Slash apparatus. Apparatus is two P's, right? A-P-P-A-R-A-T-U-S. I don't know if that just made it better or worse, but that's the idea. And I can't draw a knot of capillaries, but this should be more interactive. It should be, but again, I can't draw that. So, but you can see the Bowman's capsule surrounds the glomerulus. You can see the filtration membrane of the capillary endothelium, the basement membrane, and the fenestrated glomerular endothelium. Glomerular epithelium, sorry. We need another picture. Okay, y'all got it. You got that. Oh, we went way back. Okay, this is what I was drawing. Okay. Next, there are different types of nephrons. Did I put the timer on? No. I got it ready and I forgot to hit start. That feels like kind of a lot to process. So let's stop there. Actually, you know what? The next thing starts in with something completely different. So let's finish this and then we'll start with the next bit. Okay. So there are two different types of nephrons. There are cortical nephrons that are mostly in the cortex and juxtamedullary nephrons that are just next to the medulla. So the cortical nephrons are 85% of the nephrons. They are short. The loop is primarily in the cortex. The blood supply is the peritubular capillaries, which are the capillary beds in the cortex, and they do most of the reabsorption and secretion. The juxtamedullary nephrons, which is what it says under my head here, are closer to the medulla. They're this deepest layer just next to the medulla, juxtamedullary. So be careful here, because in one video we've had juxtaglomerular, which is just next to the glomerulus, and juxtamedullary, which is just next to the medulla. So they are descriptive. They are not interchangeable, but they do both start with juxta, and you just learn them both all at once. So juxtamedullary nephrons are near the medulla. They are 15%. The nephron loops are long and they go deep into the medulla. The blood supply is paratubular capillaries for the part in the cortex and the vasa recta in the medulla. And they produce a more concentrated urine, and we will discuss in great detail exactly how. Okay, and that's what I wanted to cover. All right, so that has been A&P 2, lecture test 5, video 5, page 10, and most of 11. Thank you, as always, for tuning in. I apologize for being sleepy, but the education must go on. Dr. J out.